I didn't get to yesterday. And not long, I actually only have 2 slides to do. We did get most of them done yesterday. So yesterday we did talk about this first fundamental theorem of calculus. The first fundamental theorem of calculus, again, informs us how we evaluate a definite integral, which is one that's going to have numbers on the integral sign. Basic idea, we find the antiderivative first, like it is an indefinite one, except don't have to worry about the plus c. And then the order we plug it in is super important. Plugging in the top number minus plugging in the bottom number. We know now that the definite integral does represent the net area. So like the last question we had ended up with yesterday was this particular problem where I gave us the graph of this region, and we had to graph it, figure out the region, and then we could find the indefinite integral and then the definite integral, plugging it in to find the exact area of that region. So the one example I wanted to look at today, I chose it mainly for the pre-calc skills and not necessarily the calculus skills, because it does involve solving a trig equation. And then we'll look at ones of like what to do if we don't have the function in front of us. So looking at this particular function, I have y is equal to the cosine of x plus the square root of 3 sine of x. And it asks us to find the area of the shaded region. So not to get too repetitive, but now we know that area is the same thing as the definite integral. So we do want to set up a definite integral representing that area. Remember, for my class and the AP exam, always show your setup in order to maximize the points you earn. So we know that this answers question, we're going to start it off with an integral of something with respect to dx. And I can kind of clearly see that the function we're integrating is this cosine of x plus the square root of 3 sine of x. And then if we're finding the area of this region, we basically want to figure out where this region is starting at and where this region is ending at. Pretty easy to see that we are in this first quadrant, so we are starting when x is equal to 0. What we don't know quite yet is where this region is ending at all the way over there where it crosses the x-axis. So that is what we need to find, and that's really where the pre-calc skills come into play, which again is what I want to focus on for this particular problem. If I want to find where that is intersecting at, I'm basically finding the x-intercept of the function cosine of x plus the square root of 3 sine of x. Well, how do I find the x-intercept? We're just going to set this function equal to 0. It's probably been a while since you've solved trig equations that look like this. They have both sine and cosine in them. They're not squared, so we can't use a Pythagorean identity. Probably easiest to solve using like tangent or cotangent. I tend to prefer tangent over cotangent just because it's a little bit easier for me to think about. So if I subtract cosine from both sides, I end up with this. How can I end up with tangent? I know that sine over cosine is tangent, so I'm going to go ahead and divide both sides by cosine. Again, why do I want to do that? This sine divided by cosine is tangent. The cosines cancel out, leaving me -1. So that original equation solved is the same thing as saying the tangent of x is equal to -1 over root 3. Some of you might have memorized your unit circle and think of it a little bit better as -√3 over 3. So basically what we're looking for is the x value that solves this equation would be the stopping point for that region. Just to review the unit circle, tangent's going to be first negative in that second quadrant. Tangent would have that value of -1 over root 3 if sine has the 1/2 and tangent has the root 3 over 2. Second quadrant means x is negative. What angle is that on the unit circle? That is 5 pi over 6. Bringing me to my intersection point of x is equal to 5 pi over 6. So that's the x value we have up here. So that's going to be the stopping point for my integral sign. Questions so far? All right, so to me, that was the hard part, in all honesty. I think the pre-calc part of actually finding that top value, the calculus, especially once you know the formulas, are pretty straightforward. So I'm going to go ahead and find the antiderivative. The derivative of sine is cosine. The derivative of negative cosine would be positive sine. Square root of 3 is just a coefficient. And I have my numbers on that vertical bar to show that I still need to plug them in. And then we just plug it in. Always remember the order. Plug in the top minus plugging in the bottom. So I'm going to have the sine of 5 pi over 6 minus the square root of 3 cosine of 5 pi over 6 minus the sine of 0 minus the square root of 3 cosine of 0. Those parentheses are important. Just make sure I don't really mess anything up. The sine of 5 pi over 6 we said was 1/2 already, minus the square root of 3. The cosine of 5 pi over 6 is negative root 3 over 2, minus sine of 0, cosine of 0 is 1. You can technically leave your answer like that last line. Like, I honestly would not mark this wrong. You've evaluated the trig, that is the area. It does simplify somewhat nicely. This becomes 1/2 minus, then a plus, 3 over 2 plus the square root of 3. 4 over 2 is 2, so we can see that the exact area is 2 plus the square root of 3. I can use the exact area here because this never goes below the x-axis, so I know the net area would be equal to the exact area. Questions on that problem?
I'm just trying to, like, how we got 5 pi over 6 is just kind of confusing, because how yesterday we got, like the second number was 2, but, like, 5 pi over 6 is on the other side of the x-axis.
So you have to make a difference in your head between, like, the unit circle, which is what we use to help us find radian measures. But remember, like, for trig, like 0, like this is just the x-axis, so like it's all in a straight line. Like, it's the unit circle kind of unwrapped. Like, if you just think about regular trig, like 5 pi over 6 and all those just keep continuing along the x-axis. So there's a difference between talking about like the angle in the unit circle and then just like the x value on the graph of the function.
Okay, I see. Thank you.
You're welcome. Any other?
I have 2 questions, Mr. Brown.
Yes.
Will you
Armani.
always set it equal to 0?
Short answer, no. Longer answer, yes, if what you're trying to find is an x-intercept, which for us, most of the time, that's what we're going to be doing.
Okay. Also, in the second step, when you were integrating or plugging it in, you have cosecant. Was that on? Or oh no, I just can't read. Sorry. Never mind.
Oh.
I thought it said cosecant.
Probably just my message handwriting. No, that's the cosine.
It's good. Okay.
There we go.
Never mind. Thank you.
You're good.
Hey, Mr. Brown.
Yeah.
So when you're finding the x-intercept and it's x equals 5 pi over 6, why isn't there 2 answers? Is it
Good question. So yes, tangent would be negative given in the fourth quadrant. But if I'm talking about like the second answer, like that's going to happen further down on the x-axis. And the region is bounded between 0 and the first time that value is equal to -1 over root 3. So like there are more like this. We know this is a periodic function. It's just going to keep going. But we're only talking about this first region on the graph. So like realistically, it probably looks something like this. We only want that first one because we're just talking about that first region. We're kind of ignoring all the ones after it.
Okay.
Any other questions? All right, last slide we're going to do is one that we skipped previously because I wanted to do the first fundamental theorem first. And I call this topic integral arithmetic. A lot of students can figure this out, honestly, without me explaining it because to them it's very logical as long as you know like what the definite integral represents. It represents net area. And as long as you remember the rules of like when that we consider that area positive and when we consider that area negative. How these problems look, they're often very frequently like multiple choice questions on the AP exam. They'll give you like some given information. So like we're told the integral from 0 to 2 is 5. We're also told the integral from 0 to 6 is 4. And we can use that information to kind of answer all the remaining questions that we see. Some of them are going to be real short. Some of them might take a little bit more work. For example, I think this first one's pretty easy. If I know the integral from 0 to 6 is 4, if I have flipped those around and said the integral from 6 to 0, what is that integral going to be equal to?
-4.
-4. Moving backwards, just change the sign, easy enough. I think the second one is also kind of intuitive. If we have said that the definite integral represents the area under the function, by multiplying a function by 3, we are stretching it by 3. And if you stretch a function by 3, then it's going to be like obviously taller. It's going to be further away from the x-axis. So we're probably also going to multiply the area by 3. And if that's the thinking you would do, like you would definitely be correct. I think a more obvious way to see this one is that just like with the derivative, coefficients carry straight across. So you cannot move variables on the outside the integral sign, but you can move constants or coefficients. So if I say 3f of x, that's the same thing as saying 3 times the integral of f of x. Well, the integral from 0 to 2 is 5, so this net area would then be 15. Questions on those two? Yes, Lily?
Would you have to show the first step, or can you just write 15?
You can definitely just jump to the 15.
Okay.
The one where students always seem to mess up on, like I'm going to put lots of asterisks by this one. For some reason, I say it every year, like someone's going to mess this problem up. Happens in both my AB and my BC class. People are still going to mess it up. So I'm going to try to fix that and show you the wrong answer first. And so when you look at this one, this is the integral from 0 to 2 of 3 plus f of x. The wrong answer that I see all the time is people are like, well, I know the integral from 0 to 2. The integral from 0 to 2 was 5. And I'm just adding 3 to that, so I get the answer of 8. I can't tell you how many times I see that. Also, the number of times I see it, it's always completely wrong. What makes this one tricky is that when we're adding 3 to a function, that means we are shifting it up by 3. Which if you imagine shifting a function up by 3, we're adding like a whole bunch of area underneath it, not just 3 units of area. We're adding a whole lot of area under it. The better and safer way to do that problem is to just split it up into 2 integrals. And what I mean by that, treat 3 like its own function, and then add to that the integral of f of x. We now already know the integral of 0 to f of x. That was the given information. That was 5. With the first FTC, we now know how to integrate 3. That's going to become 3x. Plug in the top minus the bottom. 3 times 2 minus 3 times 0. 3 times 2 is 6. 6 minus 0 gives you 6. The correct answer to this integral is 11. Not the 8. So I strongly recommend splitting it into 2 integrals whenever you're adding or subtracting a whole number, or else you're probably going to get the wrong answer. And then the last one we have, again, many students can kind of figure this one out a little bit logically. I'm going to zoom out so the font's going to get a little bit small. But we were provided with the integral from 0 to 2, and we were also provided with the integral from 0 to 6. The question is asking us to find the integral from 2 to 6. Most of us could probably figure that out in our heads. Conceptually, what's happening is if I have the integral from 0 to 6, that's the same thing as saying, well, let's go from 0 to 2. and then go from 2 to 6. So we can like split these regions up into smaller ones. I know that the integral from 0 to 6 is 4. I also know, because it was told to me, that the integral from 0 to 2 is 5. I don't know the integral from 2 to 6. Well, if the net area is 4, and I have from 0 to 2 is 5, what has to be remaining to give me 4? Clearly, -1. And I think many people can do that kind of without writing it out. But that is kind of an idea also that we can do with integrals. Like, we don't have the graph in front of us. We don't know the function. So we kind of just have to use like our logic to kind of figure out the answer to it. Any questions on those 4? All right, so I am going to kind of wrap up class now. Told you today was going to be a short day. Did just want to talk about the homework, and then I will let you go. And the homework, I'm going to go here. The homework I want you working on is homework number 3. That's the one dealing with definite integrals. I know many of you started on it yesterday, which is great. It was pointed out to me, this is definitely my mistake. I accidentally did not share with you numbers 44 and 48 with you. Normally, I would tell you just not to worry about it if it was my mistake, but those are the only 2 questions on the homework dealing with like the integral as a geometric area, and then the integral kind of arithmetic, like that last example we did in notes. So I don't want us to not do them, because it definitely is an important skill that I want you to have practice with before the test and clearly the AP exam. So I shared this as a post in Teams. Like, don't worry about like copying this down right now, but it's posted in that main news feed in Teams. I left off questions again, 44 and 48. They look long, but they actually are pretty quick to do, because you're just finding like in 48 the area of like some rectangles and triangles. 44 also pretty quick and easy to do. But that's my mistake. Definitely want to make sure you do those. Not expecting you to get a lot of stuff done over the long weekend. I do want you to enjoy the long weekend. When we come back from the long weekend, we are going to be doing U substitution. We're going to be spending 3 days on it because it is that important for you to get down. I also have planned out 3 days to review, which is probably a little bit more time than you need. But I did want to just kind of have extra time to review, especially since we did start this unit with kind of like the shortened periods and making sure that you had enough time to ask questions and all that. If you are the type of student who wants to get ahead, you can start working on your quiz corrections. For those of you new to me, I do them the same way Miss Kennedy does. But again, you have plenty of time to get those quiz corrections done when we do like the official review at the end of the unit. So like, I'm not expecting you to start that now unless you're just the type of student who wants to get ahead. So that being said, like, that's going to be the end of class today. It is Friday, so I guess you're good to go. Might want to go ahead and knock out some homework if you haven't started that homework 3, so you'll appreciate yourself a little bit more next week.